Hello, my name is DongHo Kang, and this video is for the 10-minute paper explanation series. I try to explain my first paper because I am usually focusing on the autonomous UAVs for structural monitoring. I'm sorry. So this video is for the easier understand or re-implement our papers because these days there are lots of research and then people using the UAVs and also the computer visions like deep learnings. And then I just want to give a tip and then also try to explain the very simple version because this paper is really long because I add a lot of experiment and then I also try to add lots of trial and errors and then this paper is computer aided civil engineering, civil and infrastructure engineering. So we try to make good papers to explain lots of things. This videos is, not only this video, also next videos and future videos, or try to explain as a short version because there are lots of papers these days and then research. I believe that research scientist, any other research scientist, just want to get the information very quickly. So first, traditional structure as monitoring approaches usually require a dense array of contact sensors. However, if you are using the UAVs and also the computer vision algorithms, you can get your sensor data more easily. And then you don't need any dense array of sensors in that case for surface damages. However, usually UAVs is highly dependent on the GPS for their localizations. However, GPS is not working in the indoors, so we're using the ultrasonic beacon systems for localizations in the indoors. And we're also using the convolution neural network approaches for damage localizations. So for the re-implementation of papers, we keep explaining the two different UAVs. So you can fabricate your own UAVs. However, it's really difficult and time consuming. I strongly recommend just using the commercial UAVs and then equip the ultrasonic beacon system on the top of the UAVs, and then you can just make some simple position controls using by the PID controls. And in the case, it's really less burden of your systems. Your implementations. And then after that, you need sync your mobile beacon log, and then the video result. And then you can do some image geotaggings, and then you can localize the damages from the images, and then after that you can update your geo information systems about your structure information. So for the tips, you need to set as your frame per second as much as high instead of the resolution for if you wanna using the videos. If you just wanna using the high resolution images, it's also fine. But in my case, I just using the videos. It's dependent on your case. So as I mentioned, you need to install the ultrasonic beacon in the top of the UAVs because it is really good for noise. Otherwise, something is blocked your ultrasonic beacon systems or GPS, where it's not, you cannot get the good localization result. Because UBS's basic concept is there are 4 different stationary beacons, and then these stationary beacons can give the triangular result of the mobile beacon systems, and then this is signals can send your laptop using by the routers, and then these routers calculate your drone softwares and also your beacon result, and then fuse them together, and then you can do some PID controls yourself. So we using the convolution neural network. However, you can do also pre-train. You can using the pre-trained network, and then you can get the same result because I recently tested the Inception V3 pre-trained network using my TensorFlows, and it also working really well. Also, one of the reasons I strongly recommend using the commercial UAV because you don't have to worry about this low-level controls. Instead, you can just using the position control, and then you just need sensor fusions for your mobile beacon and then IMU data. So actually, the implementation result is really good. What I suffer from around the 30 centimeters, I think. But usually you should give a 1 meter slack for when you're using the GPS or any other UAVs, I think, because in the outside you have the wind, and also even if you do some position controls, wind affect your controls, so they need the slack to recover the path. And also you need trajectories, and then so as a trajectory result, actually this is not that big errors. And also there is some tip that you can actually cropping the images like this, and then you can make tons of image data for using by those data augmentation for crack detection, because crack actually is really difficult because you don't have any public data sets. So I strongly recommend this way for your future research. So as a result, we can get very high accuracies and also very high sensitivities and specificities. So if you are looking for the autonomous structural health monitoring, I strongly recommend these implementations or making by yourself, and then try to improve your implementations. It's really good for you, I think. And thank you so much for watching these videos.